Hello everybody, and welcome to the second video on loops. So loops, as I said in the previous video, are foundational to computer science. They are extremely powerful. They also take quite a bit of getting used to, especially if you want to see how powerful they are. So in this video, I just want to show you a few more examples to get you more comfortable with the idea of a loop. And then we'll talk about nested loops. So you can have a loop inside of a loop, just like you can have an if inside of an if. And hopefully these examples will get you more comfortable with loops. So here's one application of a loop. You can use loops to count things if you want. So let's say you sit down at a roulette wheel with $1 in your pocket. So if you don't know what a roulette wheel is, it just consists of red slots, black slots, and green slots. And the dealer, or whatever you call it, the casino worker, sort of spins a marble around, and wherever that marble lands determines what you win. So you can win red or black or green or whatever. So if the wheel is broken and it's always landing on red, that just means that you would bet red. You would say, I'm going to bet that that marble lands in a red slot. So assuming you bet all the money you have in each round, how many bets will you have to make to reach $100,000? That's the counting question here, okay? So betting all the money you have means that you double your money if you win. So I'm going to bet $1, and then I'll get, at the end of that first spin, I'll have $2, because I'll double my money by winning. And then 2 will become 4, 4 will become 8, etc. Okay, so what might that look like? Well, you would start with $1 in money, and then so far you've made no bets, right? You haven't started this yet. If you wanted to count how many bets it takes to get you up to $100,000, you would write a loop that looks like this. As long as the amount of money I have is less than this $100,000 target, please take the amount of money I have and double it for me. And every time that happens, I've just increased the number of bets I've made by 1. Okay, so let's talk through what this loop does. So money is 1 at the beginning, right? 1 is less than 100,000. So we'll go inside the loop. Money becomes 2 times money, so money now has value 2, and then the value of bets becomes 1. We've just made a single bet. Okay, so now money has value 2, so this condition is still satisfied, so we'll repeat this, right? And we'll keep doing this until we get past our target, at which time bets will keep track of the number of bets I had to make to do that. So let's just put that over in the compiler. So I start with a single dollar. I start with no bets made yet. And as long as I haven't reached my target, I'm going to keep making bets. So money is twice money. Bets plus plus, and at the end of this, it will tell me how many bets I had to make to do that. Okay, it just prints to the screen 17. So it took me 17 bets to do that. So it just did that counting for me. You know, I didn't have to do that counting. And the nice thing about this logic is, suppose that $100,000 isn't your target. Suppose that you want the user to let you tell you a target amount. So, and target amount, and then ask the user, what's your target? And you get it from them. Okay, now you can just replace that 100,000 with whatever amount they gave you, you know, and you can count how long it will take to get that amount. So let's just run this. What's my target? Well, maybe my target is $100,000. 17 tries, as we knew already, right? Well, maybe I want $1 million. It's going to take you 20 bets to get there. You know, so amazing. So this is malleable, right? That's nice. Okay, so there's one example of how you could use a loop to count something if you want to reach a certain target level of betting or something. Okay, the next example I want to show you is called a factorial calculator. So if you've forgotten what a factorial is, if n is any whole number, n factorial is the number n times 1 less than n times 2 less than n, etc. And you keep going until you get down to the number 1. So 3 factorial is 3 times 2 times 1 is 6. 4 factorial is 4 times 3 times 2 times 1 is 24, and so on. Okay, that's what a factorial is. So let's write code that lets the user enter an n value, and then what you print to the screen for them is the factorial of that. And yeah, so it's worth pointing out, it's unfortunate, right? We only have so many symbols in English, right? So this exclamation mark is not the not symbol in C++. It's the factorial symbol. It means it's the mathy exclamation mark, not the computer science exclamation mark. Okay, so what might this look like? Okay, so let's just type it over here. So we have a few different variables going. The n variable they're going to give us, the factorial result, and m. So this is going to keep track of something here in a second. Oops, comma. Okay, so give me your number, and then we're going to grab it from them. Okay, so what should we do here? I've outlined the code here. First, what I'm going to do is I'm going to create this counter variable, this m. What it will do for me is it's going to keep track of where I am in the sequence of decreasing numbers. So m is going to start at n. So I'm going to set m equal to n at the beginning. So if the user enters 10, then m will initially have value 10. Okay, and factorial is also going to initially have value m also. Okay, so at the beginning everything equals 10, whatever, right? So since m is keeping track of where I am in this decreasing sequence, m is going to start at 10, then it will become 9, then 8, and so on. What I need to do is I need to set up a loop that says, hey man, as long as m is bigger than or equal to 1, I want you to decrease it, and then factorial should be whatever it is times the current value of m. Okay, so let's talk through the logic here. Let's say the user enters the number 10. Then m becomes 10 and factorial becomes 10, right? Everything's 10. Okay. Since 10 is bigger than or equal to 1, the first thing that will happen is m minus minus, so m now has value 9. So factorial takes on the value factorial times m. So remember, factorial had value 10, and then m now has value 9. So factorial, after one pass through the loop, has value 10 times 9. Okay, but m has value 9 right now, so this statement is still true. So then we decrease m by 1, and now m is 8. So factorial now is factorial times 8, but remember, factorial used to be 10 times 9, so now we're just hacking in times 8 at the end of that. So in the end, factorial should be 10 times 9 times 8 times 7 times 6, etc. And this m variable is just keeping track of where I am in that descending cascade of multiplication. So let's come back in here and put that code in there and see what it does. So factorial equals m. Oops, and I skipped a step, right? First I have to tell it what m is, right? So by the way, if that line of code is not there, this line of code won't make any sense to the computer, right? M currently has no value. So you're saying, hey, give factorial the value of something. Who knows, right? But if m equals n is right there, then m has a value. Therefore, factorial takes on whatever value comes out of that. Okay, so as long as m is bigger than or equal to 1, what should happen? Decrease the value. Factorial should be factorial times m. And then when I'm done with that, I'll just print the data to the screen. So n factorial is, whatever that factorial number was. So let's run this and see what it does. Give me your number. Okay, let's give it 3. We know that 3 factorial is 6. Well, it reported back to me that 3 factorial is 0. That's bad, because 0 isn't 6. Maybe it's a fluke. Let's type 4. 4 factorial is 0. Well, that's also bad. Factorials generally don't just die to 0. Okay, it's telling me that everything is 0. So what happened here? Why would everything be 0? Because when I was talking through the logic out loud, it seemed to make sense, right? Let's go back over here. So if the user enters 10, right, m becomes 10, factorial becomes 10, then m becomes 9, so I get 10 times 9, and then m becomes 8, so I get 10 times 9 times 8, etc. Why would everything be dying down to 0? Let's think about what happens at the end of this, okay? If m is 1, this loop is going to run, right? Because 1 is greater than or equal to 1. So if m is 1, we'll go into the loop. Oh, and if m is 1, m minus minus is now 0. So we're tacking a 0 on at the tail end of this, always. Okay, so let me just say that again. We've told this loop to run as long as m is bigger than or equal to 1. So if m is equal to 1, this loop will run. And then when we hop into the loop, the first thing we do is hit m with a decrease by 1. That means that at the end of this loop, at the very tail end, we're tacking on a 0. We're going 1 too far. So these sorts of errors are quite common when you're first dealing with loops, that you might go 1 too far or 1 too few. So let's just not go all the way to the end, right? Let's just do bigger or equal to 2. So what will happen here is, if m is 2, then m will become 1 right here, right? So 1 is not 0. It's not going to kill things. So 3 factorial is 6. Okay, good. That's what we knew it was. 4 factorial is 24, etc. Okay. So anyhow, you just have to play around with this sometimes if you see errors like that. If you insist on having an m bigger than or equal to 1 there, you can also fix the code just like this. Like, hey, you actually don't have to start. I take that back. I think I was about to contradict myself. Let me quit while I'm ahead here and keep it as fixed. Okay, we don't have to have 2 fixes, right? Okay, so anyway, so there are 2 more examples for you. A factorial calculator and some sort of counting calculator. You know, you don't want to count this yourself. Just write a loop that does the counting for you. Okay, so let me just conclude this video by saying that you can nest anything you want. You can have loops, inside of ifs, inside of other ifs. You know, you can have anything inside of anything else. Now, if you have a loop inside a loop inside a loop inside a loop inside a loop, that is pretty confusing to read as a user. The computer can understand that, but as a user, as a reader, as me, and as a user, as you, that can be pretty hard to understand what's happening. So generally speaking, we don't nest too much. If you find yourself nesting too much, you should probably just find a different way to do it. But let me just take this program here and show you how you can introduce nesting into it. So let me run this again. So give me your number, 4, you know. Well, it tells me 4 factorial is 24, but then the program stops, right? It's over. Well, what if I don't want to hit this play button again? What if I just want to, like, type 5 next or something, right? Or 6, and just have it do the same thing again, okay? How would I do that? How would I keep the program going rather than having to be like play and then all that gibberish show up on the screen and then have to enter number again, okay? How would you do that? Well, what you'd like, I think, is right after it prints this, ask the user, do you want to do this again? Oops. And, you know, you get a response from them. And if that response is yes, then they should get to go again. Now, it's yelling at me because I haven't declared a response. Let me do that. Oops, not strong. String response. Okay, so string response now. So right here, do you want to do this again? And let's actually tell them, like, we want either a y or an n. You know, we'll give them some parameters for their input. So what do we want to have happen here? What we want to have happen is if they enter a y for yes, what we want to have happen is we go right back up here, don't we? We want to be able to jump back up here and just do the same code over again. And then if the user says yes again, we want to again jump right back up here to the start of the factorial stuff. So how could we make that happen? Well, anytime you want to repeat the same lines of code, right? Anytime you want the code to repeat until the user says stop, you can use a loop. So as long as the response they're giving me is yes, I should keep doing all of this same stuff over and over again. Now, at the beginning of this code, right, response doesn't have a value. So it's not clear how the computer will treat this at first. So let me just set or initialize response to y so that this code will run at least once, and then the user can decide to terminate if they want to. So the way this code will work is response is y, so I'll do the factorial stuff once, right? And then at the end, I'll ask the user, want to do this again, buddy? If they say yes, then this condition is still true, and I'll jump back up. So now we have a loop inside of a loop, right? So the indentation here doesn't look that nice, but let's just run this and see what it does. Oh, give me your number. I don't know, 10, 10 factorial is that. Do you want to do this again? So I should have put a new line here, right? But let's just go with this. Sure, I want to do it again. Oh, well, give me your number. How about 5? Oh, okay, you want to do it again? Well, yes, I do. 13 or 31. Oops. This is probably not right. 31 factorial is too big for the integer storage capacity here, but that's all right. So 13. Yeah, see, so it's telling me 13 factorial is bigger than 31 factorial. So it ran out of storage space here in the integer data type. So remember, integer can't store that many digits, right? 31 factorial is humongous. So anyway, the point here is that this code will run over and over again, and if I finally hit N or something, right, all that matters is I hit something besides Y, it'll terminate. Right, so now the loop is done. There's no code after that loop. There's the closing brace of that yes-no loop, and then the code is done. So all of that to say that you can put loops inside of loops if you want to. There's sort of a global loop here that will keep running as long as the user wants it to. And inside of that loop, you have a factorial calculator loop, And inside of this big loop here, you can have if statements. So like, I don't know. Let's say that if factorial is more than 1,000,000 or something. Maybe you want to tell the user like, I don't know, that's a big factorial. I don't know, whatever. Okay, oops, not biff, but big. Anyway, now you have a loop up here, a while loop, and inside of that you have an if statement. So you can just do this, right? You put anything inside of anything if you want to. So give me your number, I don't know, 13. 13 factorial is this big thing, right? And it tells me, that's a big factorial, yo, But if I just do like 5 factorial, it doesn't give me that message because it doesn't go into that if statement. And then now I'll hit no at the end and I'm done. Okay, so hopefully at the end of this video you are more comfortable with what loops can do. In class, you will be writing some more sophisticated programs. We're finally on the cusp of writing powerful, real, sophisticated programs, okay? Once you have loops and once you have if statements, the combination of those two things are incredibly powerful. So in the interest of time, I haven't shown you a super powerful example because they take longer to build, but you can get sort of a taste of it here with this factorial or this betting thing, right? So this betting example is sort of an intro into like a betting program, right? So writing a program that lets a user play blackjack or roulette or poker or something. This is sort of a really, really small dip of the toe into such programs, okay? But finally, after however many weeks we've been together, we're at the cusp of writing really nice, really powerful programs. So that's what we'll start doing in class.